The next operator that we're going to be talking about is the logical operators. And so again, somebody asked before about the exclamation point. And so that in C#. Okay, so one equal sign, sorry, this is the question, guys. But one equal sign is initialization. So I guess I'll just go back to the code again. But it's like this equal sign, this is one equal sign. This is initialization. All we're saying is that this statement equals this value, while a double equal sign is equality. So we're asking the computer basically, is 7 equal to 7? So that's all that sign is talking about, like just being careful about how many equal signs you used. So this is relational. Okay, so logical operators. The operator with the exclamation mark is a C++ operator for the Boolean operation not. So again, this is something I talked about when somebody asked, like, can you use exclamation marks? You can. It's actually an operation. It's an operator that basically means the opposite of not. So logical operators, if you guys have heard of this before, it's and, or, and not. And these three things actually are important because of logical gate circuits. So these are actual circuits, and this is how your computer even runs. And so what it does is actually take this information and does a bunch of operations to it. And so you can like basically simulate those same operations using your computer, using computer code. So this might look a little intimidating at first, but trust me when I say this kind of makes sense, and it's intuitive sense too. Like, you guys understand these things. So the three operators you have is not, which basically inverts any value into the other value. So let's say, for example, I have a value of true. If I put a not statement, it inverts it, so it becomes false. So any statement that is true, any value that is true, automatically becomes false when you have this not operator. The opposite is true in the other circumstance. So if you have a false value and you put this not operator, it becomes true. So again, returns the opposite Boolean value of valuing its operand. Now, the operators that you have available to you are and or. And so the and operator corresponds to, with these double ampersand signs, corresponds to an and, which yields true only if both operations are true. So, for example, like let's just look at this table first. If you have an and operator, right, and you have A and B, an and operator basically means that this entire statement, A and B, is only true if both of these are true. So it's like a pattern, think about it. You have one true and one true, so it always equals true. But anytime you even have like one false, everything is equal to false. So both values A and B are false, so the entire statement is false. Only one of these values is false, still the entire statement is false. It doesn't matter even which one that value is, the entire thing would be false. But it's true if and only if A and B are true. And I'll explain this again in like another way, but just like think about it for a while. Then we have the or operator, which yields true if either of its operands is true. So it's like either or. So only one of these has to be true. And I guess like just for clarity's sake, A and B are operands because it's something that's like part of like the entire operator expression. So in this case, we're basically saying that if only one of these is true, then the entire statement is true. So here both A and B are true, so obviously it's true. And this one, even though only one of the operands is true, the entire statement is true. This is different than an and operator. When only one of these is true, the entire thing is false. Because if only one of these is false, then everything becomes false. So you can kind of see that opposite here. So like here's where you have true, here's where you have true, here's where you have false, and here's how you have false. Don't worry, I'll show you like in code and more conceptually what that means. But that's just basically what the different operators are. And so, yeah, you only use logical operators when it's necessary from left to right. This is known as short circuit evaluation. We'll talk about that a little bit later when I first go more into depth what these operators really mean. But right now I wanted to try like an example exercise, and I'm actually going to do it with you guys just so you can see what I'm talking about. But let's say we have like another Boolean statement, right? So we'll say Boolean statement combined. So we said that 7 equals 7. That's a true statement, right? So this is true. And statement number 2, which is this one, is 10 is less than 15. That is also true. So this is a true statement and this is a true statement. So you can think of this like as statement 1. So if statement 1 is true, you can think of statement 1 as like operand A, and then statement 2 is like operand B. So what we're going to do is combine it. So we're going to use the AND operand. So A and B. This is what we just learned, right? So if we do like a statement combined of 1 and 2, basically we say statement 1 and statement 2, right? And we try printing this out into our, if we try printing this out onto our actual code, then we'll see that it's true, like the final statement is true. And that's because both parts of our operation is true. If we run this, think about it. We said that for an AND statement, it's true when both operators are true. So both our operands are true, sorry. So we just defined that both of these operands are true. Statement 1 and statement 2 are true. So when we use an AND operator, then whenever we print out the result, it should be true. So we should be getting 1. So let's try it. Again, there we go. That's all it is when we're talking about AND. So let's try it again. If we say, instead of saying like this is true, then we'll say like bool statement 3. Let's try some like false statements, right? So we know that 10 less than 10, that's going to be false. And this is operand C, right? Because 10 is the same number as 10, so it wouldn't be equal to each other. So that's a false statement. And if we have a Boolean statement for, let's say 15, or let's say that 9 is greater than 16, that's also a false statement. And this is operand T. So this is an AND statement true when both operands are true, right? Now let's try out this one. Again, A and B, another AND statement. But now we're going to get out basically showing all the cases when you use an AND operand, and that's going to get you false. So the reason you can get false is when one or both operands are false. So if we do bool statement combined 2, so statement 1 and statement 3, and we try printing out that should get us false. So that should get us 0. See? And if we were going to want to do other basically combinations of this, so statement 1, or actually let's say statement 2, which is true, and statement statement D, which is statement 4, which is true, and false, statement 4, which is false, and statement 2, which is true. So we're basically showing that it doesn't even matter what order you have. If it's like true and false, false and true, you should, no matter what, get false as your output. So you should still get 0. Nothing should change. Still get 0. And then even in the scenario when you have both being false, you will always going to get false. And 3. So statements 3 and 4 are both false. So when you put AND for both, and we combine it together, then you should still get a 0. So these are all the combinations of the AND statement. And this is what we were talking about here before. When I showed you this little table, when I talked about, okay, if operand A and B were true and our final result is true, and then changing any of these ones to become false, everything becomes false. That's exactly what I've been showcasing right here. So again, it's just like combining these different operators together. That's all AND does. So I'm going to stop here for some questions before we go on to the OR statement. So quickly, I'm just going to showcase the OR statements. So it's kind of like not really the opposite of AND, but it's different than it. Yeah, so this was and. So this wasn't the or statements. Now we're going to get into the or statements. And again, it's like the same kind of principle idea, like how you're actually going to code it, but the logic behind it is different. So these are our or statements. So it's true when only one operand is true. So again, for the and statement, we needed both of our operands to be true in order for the entire statement to be true. For or, only one needs to be true for both of them to be true. So you can think of it kind of as like the opposite scenario as this one. So I'll even like prove it to you. So bool statement combined 5 is statement 1 or statement 2. Okay, so notice how statement 5 combined is the exact same thing as statement combined. Like we're doing the exact same thing. Basically, we're having two different true statements, and this will still get you true. True and true is the same thing as true or true. So I'll even write that down. True and true equals true or true equals true. So like your final statement, the statement 5 combined, will only ever output true. And that's because at least one of these operands is true. So again, we got our 1. Now, let's try out these other ones. So bool statement combined 6 equals statement. Now you have to be careful though. Here in this case, we said these were all false in the and situation, but because and you need both of these things to be true in order for the entire expression to be true. But in the or statement, only one of them needs to be true. So in actuality, if you did statement 4 or statement 2, which this means statement combined 6 is the exact same thing as statement combined 3 over here. And then you also did statement combined 7 is the same thing as statement combined 4, statement combined 1 or statement combined statement 3. So this statement here is the exact same thing as this statement here, and you run these. So let's try running out statement combined 6. You should still get true. Okay, there you go. Now let's try it. Yay, okay. So yeah. See, even like simple coding things like grammar makes a big difference when it comes to it. But yeah, so that still gets you like your true statement here. And like the logic basically still stands. And this is different than what you saw here when it automatically becomes false, again, because one of them is true here for an or statement, the entire statement is true. But if only one is true here for an and statement, the entire thing is false. So I hope like me repeating it enough time kind of like makes sense. So again, statement 7 is 1. So the only time for an or statement that you're going to even have basically false is when both operands are false. So that's in this case when we had like bool statement combined 8 equals statement 4 or statement 3. If you remember, 4 and 3 are both false. So since both of them are false, then there's no possible way that you can get true when it comes to the or statement. So when you print out 8 through a command line, you're going to get 0. So is this making sense to everybody? Okay, cool. I talked about and or, but if you remember, there's still like the not variable. So here we have the operator. Not is a C++ operator. Whenever it inverts it, so it produces false if its operand is true, and true if its operand is false. So like code speak, all this means is like exclamation mark is the not operator. So if we have boolean value equals false, we just said that equal to false, and we print out exclamation mark value. I just wanted that. Okay. You get 1. So the entire point of using exclamation is just to get the inverse of the value. So I said my value was false. So technically you should be outputting 0, if you see. But the moment I put an exclamation point in front of it, it goes to its opposite. So it goes to 1. That's all the not operator does. So hopefully that makes more sense conceptually. So it can even be the opposite. Usually whenever I print out the value as true, then it should come out as 1. But if I put an exclamation mark in front of it, it becomes 0. Simple. But hopefully that just kind of clarifies any doubts. Now conditional ternary operators. So these are actually a little bit confusing, but I know that you guys are like really smart and you guys can figure it out. So the conditional operator evaluates an expression, returning one value if that expression evaluates to true, and a different one if the expression evaluates to false. So, for example, we have our condition here, and so this value, this result 1, occurs whenever the condition is equal to true, and result 2 occurs whenever condition is equal to false. So actually what I want you guys to do like right now is I'll go over the first example with you, and then I want you to tell me the results for the next 3, and then after that we're going to actually try coding it, and we'll see if we were right with our predictions. So this is how ternary operators basically work. I'll show you an example. So 7 equals 5, this is our first condition, okay? And so this is the condition that you can see like right up here. So we know that 7 does not equal 5. So this operation as a whole is false. So if we were going to like print this out onto our screen, our computer would print out 3, not 4, because 4 would only be printed out if the expression was true. And I want to like test it out myself actually, because I don't know if that's what's going to be printed out. Like that's how the logic works, but let's see if that's how the computer understands it as. So, okay. Let's see if it understands like this. Yeah, okay, great. So do you see? 7 equals 5. So 7 does not equal 5. We know that for sure. So the computer prints out 3 instead of 4. Well, let's say 7 equals 7. Well, then our computer will print out 4 instead of 3. So 4 will only ever be printed out when this condition is true. 3 will only ever be printed out when this condition is false. And you can do anything that you like to this condition in order to make it print out one or the other. So that's all we're doing. So the last 2 operators that we have is the comma operator. So the simplest operator ever. All it is just showing a comma in between 2 things. So it's just used to separate 2 or more expressions. So when the set of expressions has to be evaluated for a value, only the rightmost expression is considered. Okay, and then I'm pretty sure, yeah, this is the last one, the last type of operator. And so this is called the explicit typecast operator. And this allows you to move between data types. So typecasting allows to convert a value of any given type to another type. So this has been inherited from the C language. So again, C comes before C++. And it's supposed to be a preceding expression that converts like a new type into another. So all this fancy jargon basically to say we're switching between data types. So again, there are like different ways that you can do typecasting. You have this way right here, where for example, you declare a variable as I, and then you declare another variable as f. But note that in this case, I was an integer, and in this case, f was float. So you now create I to become like, you now are making like f to become an integer, even though in reality it's like a double and has decimals and everything. And this will make more sense when I show you guys on the actual screen. But this is exactly the same thing. It's just showing the different ways that you can do like typecasting. Okay, see how it becomes 3? So integers do not have decimal points, right? So what your computer automatically does is like lopside anything that is past the decimal point. So there's no longer 1 4, it's just 3. So that's what casting does. If, for example, you were going to set this equal to like a float, right, is equal to pi, and then you're going to enter that, then it would have the 3.14 as a whole. And that's all like casting really means. Like that's the point of using casting in the first place. Just like changing from one data type to another.